Let me ask one thing. What time is it where the listener is, and where are they listening from? Do let me in comment if you enjoy science that drifts slowly through deep, quiet thought. They might consider subscribing. Because tonight, the story is about water, the most familiar substance in the world, and yet the most strange. It is everywhere. It is everything. And it is always moving. The listener may believe they know what water is. Clear, drinkable. It runs through faucets, rivers, and clouds, but its story began before clouds, before rivers, before the earth had even cooled. To understand how it flows today, from the ancient aquifers beneath mountains to the tap in a quiet kitchen, we begin at the beginning, not of civilization, but of the earth itself. In the earliest days of the solar system, there was no ocean, there was no rain. There were only dust and gases drifting. The young earth was molten. Its surface was fire. Volcanoes tore open the crust, and still there was no water. But deep in the nebula that formed the solar system, frozen particles of ice drifted among carbon and silicates. These tiny specks, comets, asteroids, and chondrites, carried water bound to minerals. Not in oceans, but in molecules. These particles struck the early Earth for millions of years. Slowly, steadily, they delivered water. Some of it escaped as vapor into space, but some remained, trapped in rock, waiting. As the planet cooled, something remarkable began. Steam rising from volcanic vents condensed in the new atmosphere, and for the first time it rained. Not for minutes, not for hours, but for centuries. A relentless grey storm, one that filled the first basins and valleys, one that carved the land and birthed the ocean. The water that runs from modern faucets first fell in that storm. Billions of years passed. Life began. First in those very oceans, in hydrothermal vents, in tide pools and silty shallows. But the water did not change. Its molecules remained, recycled endlessly. Every raindrop that falls today is ancient. Every sip from a glass contains atoms that once moved through dinosaur blood, through glacier melt, through ancient Roman aqueducts, through clouds above forgotten continents. Water remembers everything. But it never tells. The early Earth was not kind to water. The sun's radiation was intense. The magnetic field was weak. And yet, water endured. How? Through a balance of cycles. The hydrologic cycle began long before humans noticed it. Evaporation, condensation, precipitation, infiltration. Rivers carved valleys. Rain eroded stone. Glaciers flattened mountains. But water also flowed underground, into porous rock, into deep aquifers, some trapped for 10,000 years or more. These are called fossil waters. They rest beneath deserts, beneath cities, beneath the listener's own home, perhaps. They move so slowly that a human life cannot observe the change. A single droplet may take 500 years to travel a few meters through rock. Ancient civilizations understood water differently. To Mesopotamians, the Tigris and Euphrates were gods. To Egyptians, the Nile was life itself. To the Indus Valley, water was geometry, channeled through planned streets and covered drains. To Minoans on Crete, water was elegance, piped through aqueducts and fountains. They observed the cycles, but they did not control them. They watched rain fall, they watched rivers flood, and they built their homes around water's moods. Even in the driest deserts, people listened. In the Andes, The Nazca people carved underground channels called pukios, guiding spring water through spirals of stone. In Arabia, the Qanat system tapped gravity to move water from mountains to oasis towns. No pumps, no wires, just earth and slope. Water flowed through carved stone, silently, faithfully. In medieval times, water changed again, not in composition, but in perception. It became feared. Water in cities was often dangerous, contaminated, carrying cholera, typhoid, or worse. So people turned to beer, to wine, to boiling. But rural springs and rain-fed cisterns remained clear. Some monasteries guarded them, measured them, built systems of aqueducts and settling ponds. By the 17th century, thinkers began to study water as a science. Torricelli weighed vapor pressure. Boyle calculated compressibility. Hooke looked at ice crystals. But still, no one fully understood how this molecule, H2O, could hold such mystery. It freezes from the top down. It expands when frozen, unlike most substances. It has a high surface tension, clinging to itself like silk. It slips through cracks, but resists compression. It dissolves more substances than any other liquid. It reflects light, but holds none of its own. It is ordinary, but impossible to replicate. The industrial age brought new forces. Water-powered wheels, then steam, then turbines. Dams rose, giant concrete walls holding rivers in place. Tunnels bored through mountains to supply cities. Pipes spread like arteries beneath streets and walls. London, Paris, New York, all transformed by the quiet force of pressurized water. Municipal systems emerged. Treatment plants, reservoirs, faucets. But few stopped to ask, where did the water come from? How far had it traveled? Was it born in a glacier, a mountain spring, a buried lake beneath ancient rock? Did it pass through a copper pipe? Or through roots of trees up into fruit, down into soil and back to cloud? Even now few know. They turn the tap, they watch it flow, and they trust it. Inside every home, water hides, in kettles, in radiators, in toilet tanks, in the bloodstream. Each person carries water in every organ. The brain, nearly 75% water. Blood, more than 90%. Even bones contain it. But water is not static. It moves. In, out, through sweat, through breath, through tears. Every exhale carries moisture. Every hour, water leaves the body unnoticed, and it must return. In sips, in fruit, in air. The water a person drinks today may have once fallen on Himalayan stone, or drifted in a cloud over the Atlantic, or been trapped in permafrost before the first humans spoke. The journey of water is a story without beginning or end. It flows through stars, ice on comets, it drips from leaves, it pools in footprints, it carves canyons, it floods, and it heals. No molecule on Earth is more traveled, more touched, more ancient, and yet it is humble. It waits in pipes, in clouds, in glass jars on countertops. Even now it moves. Beneath the floor, through a pipe, around a bend, into a tank, out through a spout, and then into a glass, clear, silent, unremarkable. But inside that glass is the ocean, the comet, the storm, the glacier, the flood, the spring, the blood of kings, and the breath of stars, and the listener drinks, and the story continues. Some believe water is passive, that it simply fills the space it is given. But this is not true. Water seeks, it probes, it shapes. Given enough time, it cuts through granite. Given enough height, it crashes through valleys. Given enough stillness, it lifts into the air without sound, without asking. In deserts, water vanishes from sight, but not from action. Beneath the sands of the Sahara lie fossil aquifers, massive underground lakes, remnants of a greener ancient Africa. They formed during the Holocene wet phase thousands of years ago, when monsoons drenched the region. Now they remain, sealed under layers of sand, untouched by sun or time. Farmers tap them through deep boreholes, drawing up water that may not return for centuries, and the water itself does not resist. It rises, then falls again, into soil, into plant, into breath. On islands, water behaves differently. Rain is precious. It lands on volcanic stone and filters quickly into the earth. People on islands build catchment systems, rooftops shaped to collect, cisterns designed to store. In places like Bermuda, rooftops are painted white, not for beauty, but for efficiency. Each roof is a collector. Each home is a reservoir. This is not new technology. Ancient civilizations did the same. In Jerusalem, massive cisterns lie beneath the city, vaulted stone chambers once filled with runoff from rooftops and streets. In India, stepwells reach deep, into the ground, elaborate staircases carved into rock descending toward water. These were not only utilitarian, they were sacred, each drop a gift, each level a ritual. Water was approached with respect, not taken for granted. The molecule itself remains unchanged. 2 hydrogen atoms, 1 oxygen, a bond bent at 104.5 degrees. This small asymmetry makes water polar. It has a slight positive charge near the hydrogen, a slight negative near the oxygen. This allows it to stick to itself, to climb walls, to bead on leaves. This gives water its cohesion, its adhesion, its capillarity. Inside plants, water defies gravity. It travels from root to leaf through xylem vessels, not with pumps, not with pressure, but through evaporation and tension, an invisible chain of molecules pulling each other upward. This is how a redwood tree, over 300 feet tall, drinks from the soil, silently, without rest, and inside the human body the same forces apply. In kidneys, nephrons filter 50 gallons of fluid per day. Water moves through membranes pulled by osmosis, guided by gradients. It does not think, but it follows the rules, and in doing so, it sustains everything. In the atmosphere, water is a ghost. It exists as vapor, invisible to the eye. At any moment, the air holds trillions of tons of it. This vapor absorbs heat. It drives storms. It carries the memory of oceans to faraway land. When conditions shift, temperature drops, pressure changes, water vapor condenses into clouds. But clouds are not as soft as they seem. Each cubic meter of cloud holds hundreds of millions of droplets. Each droplet forms around a condensation nucleus, a speck of dust, salt, or soot. Without these particles, clouds would not form. In this way, even fire helps build rain. A volcano erupts. It throws ash into the sky. That ash gathers moisture. That moisture becomes cloud, and then rain. Destruction feeds renewal, and water is the quiet courier. In cold places, water pauses. It freezes, not as a final state, but as a waiting ice is water's archive. Inside glaciers, snowfall compacts over centuries. Each layer traps bubbles of air, preserving a record of Earth's past atmosphere. Scientists drill cores deep into Antarctic ice, extracting cylinders of frozen time. From these they learn the composition of air 800,000 years ago, the cycle of carbon dioxide and methane, the rhythm of warming and cooling, and the ice still melts. Rivers form beneath glaciers, not above but below, lubricating the base, allowing ice to slide slowly across continents. Some glaciers move inches per year, some feet per day, but always they move. And when they melt, they return water to the sea, completing a loop that took thousands of years to draw. In modern cities, water is engineered. It arrives through treatment plants, filtered, chlorinated, monitored. It flows through pressure-regulated mains, up into apartments, into pipes behind walls. Few think of the journey. The average urban household uses over 300 gallons per day, not just for drinking, but for showers, laundry, irrigation, cooling, manufacturing. Water is used to make concrete, to cool data centers, to grow food that travels thousands of miles. Every slice of bread contains water, not on the surface, but in the wheat, the process, the heat. One cotton shirt takes 2,700 liters to produce. A single microchip requires ultra-pure water to etch circuits. Water does not resist its use, but it records it. In some places, water arrives from far away. The California aqueduct moves water over 700 kilometers from the Sierra Nevada to Southern California. In China, the South-North Water Transfer Project shifts billions of cubic meters annually to meet growing urban demand. And in the Middle East, desalination plants remove salt from seawater, making the undrinkable drinkable. These are not small efforts. They require pumps, energy, time, and still they fall short. Because water is not evenly distributed. It follows geography, not need. The Amazon basin holds 20% of global freshwater runoff, but much of it flows unused into the Atlantic. Meanwhile, entire regions suffer drought, where skies stay clear and wells run dry. Water does not play fair. It moves according to physics, not politics, and so humans adapt. Sometimes wisely, sometimes not. Even now, water explores new frontiers. On Mars, frozen water lies beneath the surface. On Europa, a moon of Jupiter, an ocean may churn beneath an icy crust. NASA sends spectrometers, probes, rovers. But Earth remains the only known place where water moves in all three states: solid, liquid, vapor, constantly, simultaneously. This is the triple point of water, the condition under which all three phases can coexist. It happens in laboratories, and also as on the edge of a lake, beneath a rising sun, as mist curls upward, ice floats below, and water laps the shore. No sound, no ceremony, just balance. Back. In the home, the listener turns the tap. The water is clear, cool, tasteless. But its journey was not simple. It may have traveled through fractured limestone, through rivers, through tanks and filters and ion exchange beds, through reservoirs that once held fish, through ozone, through UV, through pipe and joint, and now it waits. In a glass, in a kettle, in a mouth, and once again, it becomes part of the body. Water does not stay long. It moves, it leaves, but while it remains, it becomes thought and memory and life, and so the listener drinks, unaware perhaps that they are drinking the breath of stars, the tears of glaciers, the silence of aquifers, the voice of cloud, and still, the water says nothing. It simply continues. Inside the body, water is not simply a container. It is a conductor, a carrier, a collaborator. It cushions organs, lubricates joints, stabilizes temperature, transports nutrients, removes waste. In the bloodstream, it serves as a river, ferrying oxygen on hemoglobin, glucose to cells, hormones to distant tissues. White blood cells drift in it like search vessels, scanning for infection. The liver filters it, the kidneys refine it, the skin evaporates it. Yet the same molecule that flows through a mountain spring also passes through a neuron. In the human, brain water makes up nearly 75% of its total mass, not just around it. Inside it, every electrical signal in the brain requires ions, charged particles of sodium, potassium, calcium. These ions are dissolved in water. Without it, no thought could form, no memory, no dream, no sense of self. It is not dramatic, it is not loud, it simply moves. A neurotransmitter is released. It floats across a synaptic cleft, just 20 to 40 nanometers wide. That gap, too, is filled with fluid. All cognition is waterborne. The firing of neurons, the regulation of mood, the rhythm of sleep, the consolidation of memory, the processing of emotion. Each depends on water's presence. In sleep, water plays a new role. Each night, when the body rests and the mind drifts, the brain shifts its priority from activity to maintenance. A system called the glymphatic system, named for its connection to glial cells, flushes the brain. It is most active during deep sleep, especially in slow-wave stages. Cerebrospinal fluid pulses through the brain, clearing waste. Proteins, beta-amyloid tau, linked to neurodegenerative disease if allowed to build. This flow increases by over 60% during sleep, and it depends entirely on water. Microscopic channels open between cells, allowing fluid to wash through neural tissue. It is not a flood, it is not even a stream, it is a silent rinse, a molecular housekeeping. Without this function, the brain becomes cloudy. Thoughts slow, fatigue lingers, and so each night water renews the mind. Outside the body, water is a recorder of time. In lakes, sediments settle slowly, layer upon layer, year upon year. Each band of silt, pollen, or ash reveals something about the season, the environment, the events of a distant age. In Greenland, ice cores tell of ancient fires, of volcanic winters, of human industry. They contain soot from Roman forges, lead from medieval mines, dust from the Sahara. Water holds these histories in quiet strata, waiting for someone to read them. Even stalactites in caves, formed drop by drop over centuries, contain isotopic evidence of rainfall and drought. It is all there, in drip and freeze and flood, a quiet archive written in liquid and stone. In music, water is metaphor. It flows through lyrics. It shapes rhythm. It becomes silence. Composers write of rivers and rain, of tides and stillness, of storm and mist. But beyond metaphor there is physics. Instruments themselves depend on water. Wood absorbs moisture. Strings respond to humidity. Wind instruments rely on condensation and breath. In concert halls, sound bends differently on humid. Nights, the speed of sound in air depends on temperature and moisture. Even in art, water is never absent. It changes the medium, the material, the behavior. In watercolors, the pigment disperses in fluid. On wet paper, it feathers. On dry, it pools. The artist does not fight this. They adapt to it, because water does not obey the brush. It responds to itself. In agriculture, water is everything, not just for crops, for soil. Healthy soil is alive. It breathes. It holds water like a sponge, thanks to organic matter, humus, roots, fungi. When soil is compacted or eroded, it loses this ability. Water runs off. Floods rise. Crops suffer. Irrigation systems attempt to replicate rain. Drip lines, furrows, sprinklers. But nothing matches the precision of a storm that falls slowly over hours, allowing soil to absorb without washing away. Rain is not just water, it is timing. Farmers learn this by feel, by watching clouds, by kneeling in dirt. They do not command the rain. They wait for it, they remember it, they respect it. In religion and ritual, water is symbol and substance. It cleanses, it initiates, it heals. In Christianity, baptism. In Islam, wudu. In Hinduism, immersion in sacred rivers. In Buddhism, the washing of statues. In Judaism, the mikveh. Each act uses physical water to signify spiritual change. The water is real. The meaning is layered, and always. The feeling is one of return, to the beginning, to the womb, to the source. The use of water in these rituals is older than scripture, older than writing. It is instinctive. A baby calms in a warm bath. A mourner washes their hands. A pilgrim drinks from a spring. These actions do not require language. They require presence. And the water does not need to understand. It only needs to be. In the future, water may be currency. Already, rivers are contested. Wells are guarded. Desalination plants. Multiplied glaciers retreat, reservoirs dry. Aquifers are mined faster than they refill. The Ogallala Aquifer, beneath the U.S. Midwest, supplies water to 1/5 of American agriculture. And it is shrinking. In some regions, the ground is sinking as water is removed from below. These are not myths, they are quiet facts. Water is still moving, but not always where it's needed, not always when cloud seeding. Atmospheric harvesting, fog nets. These are tools, not solutions. Water cannot be manufactured. It can only be borrowed and eventually returned. And still it flows, in a pipe under a floor, in a cloud above a field, in a cell beneath a skull, in a glacier beneath the stars. It has no color, no flavor, no agenda, but it changes everything it touches. In every home, it waits. In every body it moves. In every age it remembers, and it asks for nothing, not praise, not attention, only space. The listener may drink tonight, they may sleep, they may forget, but the water remembers. It always does, and it will return, silently. Water in its smallest form in the molecule never grows old. 2 hydrogen atoms, 1 oxygen atom, held together by covalent bonds, bent in a V shape. It is this shape, this small asymmetry, that gives water its remarkable properties. Its polarity makes it a universal solvent. Its surface tension allows insects to walk upon it. Its density anomaly, where ice floats, protects aquatic life in winter. Its specific heat capacity regulates climate and cools the body. No other compound behaves quite like water. It expands when it freezes. It absorbs more heat before boiling. It dissolves more substances than any other liquid, and it clings to itself with invisible cohesion, forming droplets, waves, tears. These properties are not just interesting, they are essential. Without them, life, any life, would not persist. Inside a cell, water is scaffold and solvent. It shapes proteins, carries ions, regulates temperature. Even DNA, the molecule of life, coils and replicates only in watery environments. In the cytoplasm, water holds organelles like a soft gel. In mitochondria, it participates in respiration. In the nucleus, it surrounds the genome like a guardian mist. Each second, trillions of biochemical reactions occur in the watery soup of life, and none of them could proceed in dryness. Outside the cell, water communicates, not with words, but with touch, temperature, and chemistry. In coral reefs, water carries signals. It whispers the presence of predators, the proximity of prey. It delivers larval cues for when and where to settle. Fish hear in water, not through ears but lateral lines, rows of sensitive cells that detect vibration and motion. Dolphins echolocate through clicks. Whales sing across entire oceans. The sound travels 5 times faster in water than in air. Even temperature moves like a message. A warm current, a cold eddy, both shape migration, breeding, survival. Water becomes not just habitat, but language. In the world's deepest places, water hides strange truths. The Mariana Trench plunges 11 kilometers below the surface. Deeper than Mount Everest is tall. Down there, sunlight never reaches. Pressure exceeds 1,000 atmospheres. And still, life persists. Tiny amphipods scavenge on the ocean floor. Bacteria metabolize sulfur from hydrothermal vents. Some species glow, others are blind, all are adapted. The water down there is dense, still ancient. It has not seen the sky in millions of years. Scientists drop probes, retrieve samples, analyze what life looks like at the edge of Earth's extremes. And even there, where light ends, water sustains. Higher up, on mountaintops, water returns to the sky. Snowflakes form around particles in the air, pollen, dust, smoke. Each flake is a crystal of hexagons, shaped by humidity and temperature. No two are identical, though they follow the same rules. They fall in silence, covering branches, roads, eyelashes. The snow piles up, compresses, becomes ice, then glacial ice. Then flow. Each winter's snowfall is both beginning and memory, a record, a rebirth, a pause. Eventually it melts, joins a stream, flows toward valley and plain. No drop forgets its source. In rivers, water learns to move in rhythm. From trickle to torrent, it adapts. To slope, to stone, to sediment. In the upper course it cuts downward, fast, narrow, forceful. In the middle course it meanders, broader, slower, sinuous. In the lower course it spreads, forming deltas, wetlands, estuaries. Each stage tells a story. Of youth, of maturity, of surrender. Rivers are not static. They carve valleys, change direction, abandon old beds. They give and take, flood and recede, and at every bend, water remains the same, never finished, never still, always changing, never changed. In cities, water is confined. It rushes through underground tunnels, steel pipes, concrete channels. We have engineered it to be silent, obedient, invisible. It flows behind walls, beneath floors, under streets. But when systems fail, water reminds us of its nature. A burst pipe floods a basement. A clogged storm drain swells a street. A rising sea reclaims a neighborhood. The illusion of control evaporates. Water has no loyalty to our structures. It moves according to elevation, pressure, gravity. We can delay it. We can redirect it, but we cannot own it. In the past, water shaped civilizations. The Nile flooded each year, bringing silt and life to Egypt. The Indus supported vast cities like Mohenjo-Daro and Harappa. The Tigris and Euphrates nourished Mesopotamia. The Yellow River cradled early Chinese dynasties. These were not just rivers, they were lifelines. Calendars, gods, entire cultures rose beside them, farmed their floodplains, built canals, measured their moods. When rivers shifted course or failed to flood, cities declined. Water gives and it takes. Even now in satellite images, one can trace the bones of ancient riverbeds, the faded fingerprints of once mighty flows. They linger, ghosts of geography, written in dust and delta, and far before civilizations. Water fell on a barren earth. In the Hadean Eon 4 billion years ago, Earth was hot, volcanic, unstable. But slowly, as the surface cooled, steam condensed, rain fell, oceans formed. Some water may have come from comets, icy messengers from the outer solar system, others from volcanic outgassing, hydrogen and oxygen born in fire. Regardless of source, it gathered, pooling in basins, filling craters, covering rock. It did not need an audience, before plants, before bones, before breath. Water was already moving, carving the first riverbeds, dissolving the first salts, waiting for life to emerge. And when it did, life chose water as its medium, not as preference, as necessity. All cells, from the simplest bacterium to the most complex neuron, require water, not as background, as essence, and so it continues, through storm and snow, through body and brain, through pipe and poem. It does not rest, it does not age, it does not ask, it only moves. And if the listener perhaps feels distant from this flow, they need only touch their own pulse, or feel the breath rise and fall, or sip from a glass in the dark, because in that moment they are part of the same ancient cycle, the same quiet current, that once filled oceans, that once carved canyons, that once fell as rain upon stone, and still moves. In the atmosphere, water becomes a traveler. It evaporates silently from oceans, lakes, rivers, soil, and leaves, a process driven not by will, but by heat, energy transferred from sunlight to liquid, breaking bonds. It lifts invisibly, as vapor, as mist, as potential, rising until cooler layers of air force it to condense, forming clouds. Clouds are not fluffy pillows. They are structured systems of suspended droplets and ice crystals. A single cumulus cloud can weigh hundreds of tons, and yet it floats, balanced between gravity and uplift. Within clouds, water shifts forms, vapor to droplet, droplet to ice, ice to rain. Every raindrop begins around a nucleus, a speck of dust, sea salt, or even bacteria. Without this center, vapor cannot condense. There is always a seed at the heart of water's return. When rain falls, it does not fall equally. Some droplets evaporate before touching ground, a phenomenon known as virga. Others are caught by leaves, roofs, feathers. Some soak into soil, some rush overland, some gather in puddles, lakes, rivers. The path of each drop is shaped by what lies beneath: slope, surface, stone, structure. Some water enters the ground, infiltrates porous spaces between grains of sand, silt and clay. Over time it may descend to aquifers, vast underground reservoirs trapped between layers of rock. Some of these waters have been there for thousands, even millions of years. They are called fossil waters, and they move very, very slowly. When drawn by wells, it is not a cycle. It is an extraction, a memory tapped from Earth's ancient archive. Water in soil is more than moisture. It is life support for an entire underground world. Roots extend delicate hairs into wet particles, absorbing both water and the minerals it carries. Mycorrhizal fungi wrap themselves around roots, creating mutual exchanges, sugar for nutrients, water for access. Bacteria break down organic matter. Earthworms aerate the soil, allowing water to penetrate deeper. Soil that retains water supports growth. Soil that repels it turns to dust. Deserts are not dry only because of heat. They are dry because their soil cannot hold. The difference between fertility and famine can be one good rainfall and one healthy sponge of soil. In the human home, water is measured. It is piped, filtered, pressurized, chlorinated, sometimes fluoridated. Meters track its flow. Bills reflect its use. Valves control its presence, but still it retains its nature. A leak will find its path. Condensation will form on cold surfaces. Steam will rise from kettles and showers. In homes, water is warmth and hygiene and flavor. It carries coffee through a filter. It steams rice, it cleans dishes, it soaks skin. Each tap delivers ancient molecules, cycled countless times through rivers and clouds and pipes. The water is not new, only its journey is. In industry, water becomes tool. It cools turbines, drives hydroelectric dams, cleans silicon. Wafers, carries chemicals in manufacturing. To make a single sheet of paper, 10 liters. A pair of jeans, 7,500 liters. A car, over 30,000 liters. This is not water that disappears, but water that is transformed into vapor, waste, runoff. Water, used industrially, must be treated to return. If not, it pollutes at oil, heavy metals, dyes, detergents. Untreated water can poison aquifers, choke rivers, kill fish, harm humans. Water remembers what it carries, and what it carries can linger. In the sky, snow gathers silently. Crystals form, in sub-freezing clouds, symmetrical, angular, unique. They tumble down, spun by wind, shaped by temperature. On the ground, snow reflects sunlight, increasing albedo. This cools the surface, slows melting, and affects climate feedback loops. In the Arctic, snow cover insulates soil. In mountains, it stores water for spring melt. Each snowpack is a reservoir in disguise, a delayed release, a frozen promise. In spring, the thaw feeds rivers. In summer, it sustains crops. In fall, it recedes. In this cycle, snow to stream to soil to sea, water keeps its cadence. It does not rush. It does not stall. It flows. In medicine, water becomes precision. Saline. Solutions maintain hydration. Intravenous drips carry medications. Sterile water cleans wounds. Dialysis filters blood through water-intensive membranes. Each cell, each organ, depends on proper hydration. Too much water and cells swell. Too little and they shrink. The balance is delicate, tightly regulated by hormones. Antidiuretic. Hormone aldosterone, renin. The kidneys monitor and adjust. They concentrate urine when water is scarce. They dilute it when water is abundant. In fever, water cools. In digestion, it dissolves. In circulation, it transports. A human can survive weeks without food, but only days without water. It is not just needed, it is constant. In art, water is motif and method. Ink flows on wet paper, bleeding into textures. Clay is shaped with damp hands. Canvases are stretched and primed with water-based gesso. Painters dilute pigments. Photographers develop film in liquid baths. Sculptors polish stone with water to reduce dust and friction. In traditional Japanese sumi-e, a single brushstroke of black ink spreads over water-soaked rice paper, creating tones not of color, but of moisture. In Chinese ink wash painting, water becomes the guide. The artist learns to follow, not control. The result is not always predictable, but always organic. Water in art is not a mistake, it is character. In memory, water is emotion. Scent of rain can recall childhood. A beach can evoke peace. A storm can summon awe or fear. These are not metaphors. They are associations, stored in the hippocampus, felt in the amygdala, reflected in the body. A cool bath slows heart rate. The sound of waves calms the nervous system. The feel of water can induce safety, or its absence, panic. These responses are not learned. They are ancestral. Human evolution began near water. Dependence forged response. Experience became instinct. Even now, in sleep, water sounds soothe, not because they are novel, but because they are remembered, and water continues, not in chapters, not in phrases, but in movement. The story of water is not one of drama. It is not sudden. It is not loud. It is old, slow, and deeply woven. From comets to clouds, from oceans to organs, from ritual to rain, it is here, still here, always here, and even now it listens. In the beginning, Earth had no oceans. When it formed, the planet was a molten sphere, its surface too hot to hold liquid. Volcanoes raged, meteorites bombarded. The sky was thick with carbon dioxide, methane, ammonia. But over millions of years as the crust cooled and solidified, steam began to condense. Tiny drops formed. They collected, they fell. Rain poured onto hot rock for centuries, carving channels where there was no life, no moss, no sand, just bare stone, worn away by the quiet insistence of water. Over time, these drops filled the basins between Earth's earliest continents. The oceans formed, not suddenly, but drop by drop, cloud by cloud, eon by eon. Some scientists suggest that much of this water came from the interior of the planet itself, from hydrated minerals deep in the mantle, released through volcanic outgassing. Others propose that it came from space, delivered by icy asteroids, meteorites, and comets billions of years ago. This debate continues, and the answer may be both. Whether born of fire or delivered from afar, Earth's water arrived early, and it stayed. In the oceans, life began. The earliest forms were not fish or even plants, but microbes. Tiny, single-celled organisms floated in the sea, drawing energy from chemicals around hydrothermal vents on the ocean floor. They did not need sunlight. They needed only heat and water. These early archaea and bacteria were extremophiles, creatures that thrived in conditions lethal to most life today. Acidic, pressurized, dark. And yet, they flourished. Over time, photosynthesis emerged. Not all at once, but in small, cyan-colored cells known as cyanobacteria. These organisms absorbed sunlight and released oxygen as a byproduct. That oxygen began to accumulate, first in the oceans, where it oxidized iron, and then in the atmosphere. This slow, steady process transformed Earth's skies. What was once a poisonous, anaerobic world became breathable, and all of it began in water. Water shaped evolution. Aquatic animals developed gills to extract oxygen from it. They learned to navigate currents, avoid predators, hunt prey. Some grew fins, some shells. Some developed the ability to float or glow. Eventually, certain creatures moved to shallow waters, to mudflats, to tidal pools, and from there to land. But even after they left the water, they carried it with them. in blood, in amniotic fluid, in the structure of cells. They did not abandon water. They became vessels for it. Even today, every human embryo develops in a fluid-filled sac. The amniotic sac contains water, electrolytes, proteins, hormones, a private ocean, a temporary tide. And when the child is born, the water breaks, as if reminding us of where we came from. Water shaped not only biology, but language. The words we use are soaked in aquatic imagery. We speak of streams of consciousness, of floods of emotion, of being adrift or overwhelmed or immersed. We describe clarity as transparency, insight as depth, confusion as murkiness. Entire vocabularies are influenced by water. Sailors developed their own lexicons: port, starboard, stern, hull. Farmers spoke of drought, irrigation, runoff. Priests blessed with it. Doctors prescribed it. Poets dreamed of it. Languages evolved differently in wet climates versus dry. In regions with rivers, words for current and bend become metaphors. In deserts, water becomes myth, precious, rare, symbolic. Some of the earliest written laws dealt with water rights. The Code of Hammurabi, carved in stone around 1750 BCE, includes regulations for irrigation canals, flooding, and crop damage. Even then, water needed management and fairness. In time, humans became architects of water. They built aqueducts in Rome, massive stone structures carrying spring water across hills and valleys. Some ran for nearly 50 miles. They relied entirely on gravity. The Romans understood gradient. They measured slope with tools called chorobates and groma. They built settling tanks, sediment catchers, and distribution towers. Water flowed into fountains, baths, gardens, and homes of the wealthy. In ancient Persia, underground tunnels called qanats channeled water from mountain aquifers to dry plains, traveling for kilometers beneath the earth, preventing evaporation. In China, the Dujiangyan irrigation system diverted rivers without dams, using precise hydraulic engineering that still functions today, 2,000 years later. Water engineering was never just technical. It was cultural, philosophical, spiritual. To direct water was to live. But not all water management was peaceful. Wars were fought over wells and rivers. Empires rose and fell with the monsoon. Sieges were broken or made worse by access to water. The Nile's flooding dictated the fate of pharaohs. The Tigris shaped trade routes and conflict. The Mekong became a political boundary. The Danube marked empires. The Mississippi changed nations. In modern times, dams replaced floods with reservoirs. The Aswan High Dam in Egypt stopped the annual inundation of the Nile. It created Lake Nasser, one of the largest man-made lakes on Earth. Electricity, water storage, and controlled flow followed. But so did ecological change, displacement, and new forms of dependency. Every decision about water creates ripples. In religion, too, water reflects complexity. It is both purifier and destroyer. In the flood myths of many cultures, Noah, in the Bible, Utnapishtim in the Epic of Gilgamesh, Manu in Hindu tradition, water cleanses the world through destruction. It erases the past to prepare for renewal. In Shinto rituals, worshippers rinse their hands and mouths before approaching shrines. In Christianity, holy water is used to bless, to protect, to remember. In Islam, ablution is required before prayer, 5 times a day. Water is not just a symbol of purity, it is a requirement for it. Even in secular life, we wash before eating, before entering homes, after touching the world. The impulse is deep, almost automatic. clean hands, clean heart, clean slate, and still that water moves. It does not rush, it does not resist, it follows the path available. A crack in the pavement, a vein in marble, a fault in a rock. Water does not need to conquer, it only needs time. Given enough of it, water can shape any mountain, any mind, because erosion is not sudden, it is persistent. And what is true for stone is also true for thought. With enough stillness, ideas reshape. With enough quiet, truth reveals itself. With enough patience, change comes, like water over granite. In this way, the story of water is not one story. It is 1,000, of biology, of history, of geology, of thought. It is everywhere, not because it spreads, but because everything depends on it, even this moment. As the listener rests, as the breath slows, as the silence deepens, there is water moving inside them, not metaphor, not poetry, but molecule and motion, a soft flow, a distant tide, a living rhythm, and still it continues. In the microscopic world, water is not passive. It is active, relentless, and always moving. Inside every living cell, water acts not only as a background fluid, but as a participant in nearly every biological process. It carries nutrients into cells. It escorts waste out. It enables proteins to fold into their functional shapes, a process known as hydrophobic interaction. Without this subtle choreography between water and biomolecules, life could not self-organize. Enzymes would misfold, cell membranes would collapse, DNA would remain unreadable. It is not exaggeration to say that water makes life's complexity possible. It creates the stage and acts upon it. In blood, water transports oxygen, bound to hemoglobin. It carries glucose to cells, hormones to organs, antibodies to sites of infection. In the digestive system, water dissolves food. It allows enzymes to break chemical bonds. In the excretory system, it eliminates toxins, urea, creatinine, excess, salts. In the nervous system, cerebrospinal fluid cushions the brain. It removes metabolic waste, and it flows in rhythm with heartbeats and breath. All of this invisible, all of it constant. In the Earth's crust, water is a sculptor, not in days, not in years, but in epochs. Rainwater seeps into cracks, freezes, expands, breaking rock apart. Glaciers move slowly, grinding valleys into U-shapes, carving fjords, dragging boulders. Rivers meander, not because they are lazy, but because they follow the path of least resistance. Over centuries they shift their course, abandoning old beds and forming new ones. This process is called avulsion. Some rivers, like the Mississippi, have threatened to change course entirely. Humans build levees to stop it, but the river remembers its options. In limestone regions, groundwater carves underground caves. Over time, ceilings collapse, forming sinkholes. Stalactites and stalagmites grow, mineral by mineral, from the slow dripping of saturated water. Each drop leaves a trace. Each trace becomes a form. Even deserts are shaped by ancient water. Wadis and dry riverbeds mark paths once flowing. Sand dunes, moved by wind, are often formed from sediment left by vanished lakes. The absence of water can speak just as loudly as its presence. In the atmosphere, water influences weather, not by force, but by balance. Humidity levels affect how air feels. Dry air cools quickly, moist air retains heat. This difference changes how clouds form, how rain falls, how storms behave. When warm, moist air rises rapidly, it can create towering cumulonimbus clouds, the kind that bring thunderstorms. The energy in these systems is astonishing. A single thunderstorm can release more energy than an atomic bomb, all driven by water's phase changes. Evaporation absorbs heat, condensation releases it. This exchange powers the water cycle and, by extension, the global climate. Hurricanes begin as low-pressure disturbances over warm ocean water. As water evaporates, it fuels the storm. The more heat available, the stronger the system. The eye of a hurricane, calm, still, is surrounded by the eye wall, where the fiercest winds spiral, and yet it is still just water. Vapor, cloud, rain, wind. Nature's most destructive forces, made from softness. In the cryosphere, the frozen parts of Earth, water is still dynamic. Glaciers flow, though so slowly they appear still. They creak, crack and carve, breaking off into icebergs. Permafrost stores ancient organic matter. When it thaws, it releases methane, a powerful greenhouse gas. Sea ice forms a skin over the Arctic Ocean. Its extent changes with seasons. But over decades, it has steadily declined. This affects albedo, Earth's reflectivity. Less ice means more heat is absorbed. More heat means less ice. A feedback loop. In Antarctica, ice sheets rest atop land. If they melt significantly, they raise sea levels. This differs from sea ice, which displaces its volume and does not contribute to rising seas when it melts. Understanding this distinction is essential. Water frozen in ice sheets holds the potential to reshape coastlines, cities, nations, and once released, it moves quickly, not because ice is impatient, but because gravity is constant. In the ocean, water is not still. It is never still. Currents span thousands of kilometers. The Gulf Stream carries warm water from the Gulf of Mexico up the Atlantic coast and toward Europe. It moderates the climate of Western Europe, making London warmer than Montreal, despite being farther north. These currents are part of the global conveyor belt, or thermohaline circulation. Driven by differences in temperature and salinity, this deep ocean system moves water around the planet over a timescale of centuries. It connects the surface and the depths, the tropics and the poles, the past and the future. Disruptions to this system, due to melting ice or changing salinity, could alter weather patterns globally. The oceans are Earth's heat sink. They absorb solar energy. And now, much of the heat from greenhouse gases. This changes water's chemistry. Warmer oceans hold less oxygen. They absorb more carbon dioxide, becoming more acidic. This harms corals, shellfish, phytoplankton, and in harming them, it harms us. Because the base of the food chain floats, small, unseen, necessary. In the human home, water is measured. In minutes. The average shower, 8 minutes. The average flush, 6 liters. The average tap left running while brushing teeth, 9 liters. But these numbers vary greatly. In some countries, daily water use exceeds 300 liters per person. In others, it is less than 20. Access depends on infrastructure, policy, and geography, but also on history. Colonialism often redirected water toward export agriculture, not local needs. Today, some of those systems persist. Privatization, pollution, climate shifts, they complicate access further. Water scarcity is not always due to drought. It can be due to distribution or power. The paradox is this: there is enough water on Earth, but not always in the right place, at the right time, for the right people. Solving this is not just engineering, it is ethics. In outer space, water is a signal, not of life, but of the possibility of life. Scientists search for water ice on moons, on Mars, on comets. Its presence suggests stability, or past climate, or buried secrets. The moon has frozen water in shadowed craters. Mars has polar ice caps and signs of ancient riverbeds. Europa, one of Jupiter's moons, has an icy crust over a liquid ocean, warmed by tidal forces. Enceladus, a moon of Saturn, sprays water vapor from cracks near its south pole. These plumes contain organic molecules. Wherever water is found, curiosity intensifies. Even in interstellar clouds, astronomers detect water vapor among gas and dust that may one day form stars, planets, oceans. In this way, water is not just Earth's story. It may be the galaxies, it may be the universes. And so the story flows on, not just from ancient oceans, not just to homes, but through everything, in breath, in blood, in soil, in snow. It carries heat, it shapes land, it stores memory, it holds life. It cannot be created or destroyed and only moved, only changed, and in each moment it moves still. Through capillaries. Through roots, through rivers, through clouds. What once fell on a Cambrian fern now steams in a morning mug. What once flowed through a trilobite now moves in a garden hose. The same molecules, the same path, the same patience. Water is not finished, it is simply in motion. Water is not only ancient, it is also precise. In the laboratory, water becomes a constant, a control, a solvent so stable, so dependable, that many experiments assume it without question. It dissolves more substances than any other liquid. This is due to its polarity, the way each molecule has a slightly negative oxygen atom and two slightly positive hydrogen atoms. This shape, a bent V, allows water to form hydrogen bonds, temporary attractions with other molecules. It is these hydrogen bonds that give water many of its unique properties: its surface tension, its high specific heat, its ability to climb up narrow tubes, capillary action. These same bonds make water liquid at Earth's temperatures. Without them, water would boil at room temperature. Ice, too, behaves differently from most solids. It is less dense than liquid. Water. That's why it floats. When water freezes, its molecules lock into a crystalline structure that takes up more space. This is why ice expands in pipes, why frost heaves roads, why lakes freeze from the top down, allowing life to survive. Beneath, no other common substance behaves quite like this. Water breaks the rules, and in doing so it sustains life. In agriculture, water is currency. It determines planting and harvest, success or famine. Irrigation has existed for over 5,000 years, from Mesopotamian canals to the qanats of Persia, from Chinese rice paddies to Roman aqueduct-fed fields. In modern times, methods include surface irrigation, drip systems, sprinklers, and subsurface networks. Each has its advantages and its limitations. Drip irrigation is efficient. It delivers water directly to roots, but it requires infrastructure, maintenance, planning. Sprinklers are easy to deploy but wasteful in hot, dry regions. Evaporation steals moisture before it touches soil. Flood irrigation is common in many developing regions, but it leads to runoff erosion and soil salinization. The more we irrigate, the more salts build up in the soil. This reduces fertility over time. Fertilizers also dissolve in water, and excess nitrogen or phosphorus can run off into rivers and lakes. There they cause algal blooms. These blooms consume oxygen. When they die, they decay, further depleting oxygen. The result? Dead zones, areas where fish and other aquatic life cannot survive. One of the largest lies in the Gulf of Mexico, caused in part by runoff from farms along the Mississippi River. So while water gives, it also demands responsibility. In cities, water becomes invisible. It flows through pipes beneath streets, walls, and floors. It appears with the twist of a tap. Few think about where it comes from. Fewer still consider where it goes. Municipal. Water systems treat, transport, and distribute water on a massive scale. They rely on pumps, reservoirs, treatment plants. In some cities, water is drawn from nearby rivers or lakes. In others, it travels hundreds of kilometers. Los Angeles gets much of its water from the Owens Valley, the Colorado River, and Northern California. New York City's water comes from reservoirs in the Catskill Mountains, over 100 miles away. Via gravity-fed aqueducts, the water is filtered, treated, and chlorinated to ensure safety. But this convenience has its costs. Old infrastructure can leak. Lead pipes, still present in parts of the U.S., pose health risks, especially to children. In Flint, Michigan, a switch in water sources combined with improper treatment caused lead to leach into drinking water. The crisis lasted for years. It reminded the world that water systems require vigilance, even in wealthy nations. In the home, water touches nearly every activity: cooking, cleaning, bathing, drinking. A standard dishwasher uses around 6 to 15 liters per cycle. Washing machines vary, but top loaders can use 150 liters per load, while front loaders are more efficient. Showers too vary. Low-flow heads reduce usage to about 9 liters per minute. Older heads may use twice that. Toilets are major water users. Modern models use as little as 4.8 liters per flush. Older ones, over 13. But beyond quantity, quality matters. Many people use filters to remove chlorine, sediment, or trace contaminants. Activated carbon is a common method. It traps impurities via adsorption. Reverse osmosis filters use pressure to force water through semi-permeable membranes. Boiling water kills most microbes, a reliable method in emergencies, but it does not remove heavy metals or chemicals. Bottled water is popular, but not always safer, and plastic waste from bottles contributes to environmental pollution. Single-use plastic bottles, millions discarded daily, often end up in landfills or oceans. Microplastics, tiny fragments less than 5 millimeters in size, have been found in rivers, rainwater, and even human blood. Water connects everything, even pollution. Culturally, water reflects memory. In art, it represents reflection, change, impermanence. Painters have long captured its forms: the still pond, the crashing wave, the rain on glass. In literature, water is a metaphor for emotion. Storms mirror rage. Calm seas evoke peace. Floods bring renewal. In music, water rhythms soothe. Waves, rain, rivers, recreated in ambient tracks, lullabies, meditative pieces. In film, water scenes often symbolize transition. Characters cross rivers, walk in rain, dive into the unknown. These symbols are not accidental, they are ancient, because for most of human history, water was a boundary. Rivers separated lands, oceans isolated continents. Crossing them required courage and offered transformation. Water is both obstacle and passage. In science fiction, water often plays a central role. It is the scarce resource in dystopias, the treasure of desert planets, the element that signals life on alien worlds. Frank. Herbert's Dune imagines a world where every drop is sacred, where moisture is harvested from breath, from waste. In Interstellar, a water world challenges survival with tidal waves caused by massive gravity. In The Expanse, control of ice in the asteroid belt is a form of power. Even in fiction, water remains fundamental, not because we lack imagination, but because we understand its truth. Life depends on it. Real or imagined. In the body, water is rhythm. The heartbeat pushes it. The kidneys filter it. The lungs exchange it. Every blink, breath, and tear involves water. Dehydration impairs cognition. Even mild loss, as little as 2% of body weight, reduces memory, focus, mood. Overhydration, though rarer, can also be dangerous. It dilutes sodium in the blood, a condition called hyponatremia. Symptoms range from nausea to seizures. Balance matters. The body regulates hydration with hormones like vasopressin, also called antidiuretic hormone. When the body is dehydrated, vasopressin signals the kidneys to reabsorb water. When hydrated, it reduces reabsorption. Thirst is not always reliable. By the time we feel it, dehydration has often begun. That's why steady hydration, not just reactive drinking, is key. In ritual, water marks time, birth, baptism, washing, grieving. It cleanses not only skin but significance. In some traditions, bodies are washed before burial. In others, water is poured over hands to symbolize release. It connects the living and the dead, the sacred and the daily. Even in secular life, water ceremonies remain. Sprinklers on wedding days, beachside memorials, first swims, last baths, water witnesses, quietly, repeatedly. It is always present, rarely acknowledged, and yet it is ritual, and so it continues. This journey of water, from ancient oceans to ice caps to clouds, through cells, pipes, art and memory, flows not as a story with an ending, but as a condition of stories, as a presence in all things, because water is not just part of life, it is the shape of it. In evolution, water was the origin. It was the cradle from which multicellular life first stirred, not in bursts of light, but in slow waves of adaptation. The earliest organisms, simple prokaryotes, lived in oceans more than 3.5 billion years ago. These cyanobacteria released oxygen as a byproduct of photosynthesis. Over time, this oxygen accumulated in the oceans and eventually in the atmosphere. This event, the Great Oxidation Event, transformed Earth's environment. It allowed for more complex aerobic life to emerge, but the ocean was more than just a place. It was a pressure system, a filter, a buffer. It cushioned organisms from UV radiation, from temperature extremes, from gravity itself. Marine life evolved fins, gills, streamlined shapes. Coral reefs formed, partnerships between algae and invertebrates, creating habitats for countless species. Some fish eventually began to adapt to shallow waters. Fins became stronger. Some even used them to move across land. Over time, these became limbs, and so vertebrates, including all mammals, reptiles, birds, began their migration from sea to land. Even today, the human body retains signs of this watery heritage. The amniotic sac mimics a tiny ocean. The electrolyte composition of blood plasma mirrors seawater, and human embryos pass through stages resembling fish, complete with gill slits and tails. We are, in a molecular sense, still ocean beings, displaced by time but not disconnected. In the fossil record, water leaves delicate traces, imprints in mud, mineralized shells, ripples preserved in stone. Many of the most detailed fossils are found in sedimentary rock, formed from layers of silt, sand, and organic debris compacted over millennia. Lagerstätten, rare fossil beds, contain organisms so well preserved that even soft tissues remain visible. The Burgess Shale in Canada, the Solnhofen limestone in Germany, the Chengjiang biota in China. Each of these sites was once a shallow marine environment. Fossils found here include trilobites, jellyfish, sea lilies, ancient fish. Some specimens retain their pigmentation. Some reveal muscle fibers, others show gut contents. Without water, these would not exist. Sediment settles only in liquid. Preservation demands stillness and time. Water does not only erode, it also remembers. In human memory, water is both fear and comfort, floods, droughts, shipwrecks, but also baths, rains, lakeside summers, the same element holding opposing meanings. In mythology, water is transformation. In Greek myth, the river, Styx separated the world of the living from the dead. In Norse cosmology, 9 realms are connected by a great tree, with wells and rivers feeding into its roots. In Hinduism, the Ganges is sacred, believed to purify sin. Pilgrims bathe in its waters for spiritual cleansing. In Christianity, water represents rebirth. In Islam, it is necessary for ablution, a ritual cleansing before prayer. In indigenous traditions across continents, water is a living entity, respected, spoken to, thanked. These beliefs are not separate from science. They are frameworks for reverence. While science measures, culture remembers, and both acknowledge water is not inert, it is sacred. In engineering, water challenges mastery, dams. Hold it back, pipes guide it, pumps lift it, but never fully control it. The Hoover Dam, spanning the Colorado River, was completed in 1936. It created Lake Mead, the largest reservoir in the United States. It supplies water to Nevada, Arizona, California, as well as hydroelectric power, but it also flooded canyons, displaced communities, changed ecosystems. Every dam is a negotiation between benefit and cost. In the Netherlands, where much of the land lies below sea level, a vast network of dikes, levees and pumps, known as the Delta Works, holds the sea at bay. Japan builds sea walls against tsunamis. Venice installs floodgates to hold back tides, yet floods still come. Water finds weakness, always. No wall is permanent, no plan perfect. Adaptation, not conquest, is the lasting strategy. In the mind, water alters perception. Even the sound of it can soothe. White noise machines play recordings of rain, rivers, waves. Some studies suggest these sounds reduce stress, improve sleep, lower heart rate. The reason may be evolutionary. Early humans slept safest near water, but not too close. The soft gurgle of a stream indicated nearby hydration and vegetation, without the immediate danger of predators. In modern neuropsychology, the soft fascination of water scenes has been linked to restorative attention. This means water draws focus without demanding it. Unlike screens or traffic, which overstimulate, water soothes. This effect is used in architecture, fountains in courtyards, reflective pools, indoor aquariums. It is not luxury. It is neurological. Care water speaks to something ancient inside the brain, something pre-verbal, something real. In art, water is difficult to paint, to photograph, to capture. It reflects and refracts, it moves, it changes constantly. Great artists have spent lifetimes chasing its form. Claude Monet painted the same lily, pond over and over, changing only light and season. J.M.W. Turner painted storms and shipwrecks, trying to capture the chaos of sea. In Japanese ukiyo-e prints, Hokusai's The Great Wave off Kanagawa shows a frozen moment, motion without movement. In sculpture, fountains have long been used to animate stone. Bernini's Fountain of the Four Rivers in Rome is both myth and engineering. Modern. Art installations use water as medium, not just subject. Falling sheets of droplets, reflections in mirrors, pools dyed with color, but always elusive. Water cannot be held for long. Even in art, it is a lesson in impermanence. In medicine, water can heal or harm. Hydrotherapy uses water pressure and temperature to reduce inflammation, ease pain, improve circulation. Physical therapy often includes aquatic exercise. The buoyancy supports joints, reduces strain. Cryotherapy uses ice to numb nerves. Heat packs use water to soothe muscles. Even internal medicine uses water. Saline IVs restore hydration. Oral rehydration therapy saves lives in areas with limited resources. But water also carries disease, cholera, typhoid, dysentery. These are not diseases of water itself, but of contaminated water. Billions still lack access to safe drinking water. UNICEF estimates over 700 children under 5 die daily from preventable water-related illnesses. And during climate disasters, floods, hurricanes, clean water is often the first need. This is why water is not just a public utility. It is a human right, not a product, not a luxury, a necessity. In space travel, water is precious. On the International Space Station, water is recycled. Sweat, breath, urine. The environmental control and life support system processes and filters every molecule. Astronauts drink the same water many times, purified each cycle. This isn't science fiction, it's necessity. Water is heavy, expensive to launch, so every drop matters. Future missions to the Moon or Mars must find local water, either as ice or bound in minerals. This is called in situ resource utilization, because carrying water for a multi-year mission is impractical, but extracting it from regolith is possible. Hydrogen from water can also become rocket fuel, split via electrolysis and recombined, so water is not just life support. It is propulsion, infrastructure, freedom. Where there is water, there can be settlement. In time, water is patient. It does not hurry, it does not stop, rivers do not argue. They wear down stone, rain does not announce, it returns when it will, the ocean does not explain. It simply contains, and yet through all things, that movement, change, growth, water remains, from the first drop that cooled the young earth, to the vapor rising from a kettle this morning, the molecules are the same, recombined, recycled, returned. What was once a storm becomes a sip. What was once a glacier becomes a tear. What was once a sea becomes steam in a pipe. Water does not end, it simply travels. In ecosystems, water is the framework of interaction. No habitat exists independently of it. Rainforests breathe it. Deserts long for it. Wetlands filter it. And oceans, they orchestrate global life. Water is the lifeblood of the biosphere. In our freshwater ecosystems, rivers, streams, lakes, the movement and stillness of water shape the kinds of life that form within. A fast-moving stream contains oxygen-rich water. Fish that thrive there, like trout, are streamlined and adapted to currents. Still lakes are stratified, warm water on top, cold below. These layers mix with the seasons, distributing nutrients that feed aquatic plants and plankton. In wetlands, marshes, bogs, swamps, water sits between earth and sky, not quite dry, not quite submerged. Here biodiversity thrives. Frogs, reeds, dragonflies, bacteria all find equilibrium in murky shallows. Wetlands are not just habitats, they are filters. They absorb excess nutrients, trap sediments, and buffer against floods. A hectare of wetland can store millions of litres of floodwater, releasing it slowly. Yet half the world's wetlands have vanished in the last century, drained for farming, paved for construction, forgotten, and with them the life they held. In oceans, water becomes structure. Currents circulate warmth, nutrients, salt, carbon. The global conveyor belt, known formally as thermohaline circulation, moves water around the world over centuries. Warm surface currents like the Gulf Stream carry heat from equatorial regions to colder ones. Cold deep-water currents, driven by differences in temperature and salinity, flow back toward the tropics. This constant movement helps regulate Earth's climate. It is not chaos, it is pattern. But as climate changes, so does the engine that drives. Melting polar ice introduces fresh water into salty seas. This dilutes salinity, reduces the density difference that drives circulation, and in time can slow or even stall the system. If the conveyor belt stops, regions like Europe may cool dramatically. Tropical zones may become more unstable. Rainfall patterns may shift. Ecosystems may collapse. This is not a theory of someday. It is a process already underway, and all of it moved by water. Within the ocean live the largest organisms known. The blue whale, 100 feet long, 150 tons. A creature entirely dependent on the tiny krill it filters from seawater. Coral reefs, though stationary, are alive with chemical exchange. They require precise water temperature, clarity, salinity, and pH even. Slight shifts cause coral bleaching, when polyps expel their symbiotic algae. Without those algae, the coral starves. And beneath even the coral, plankton, phytoplankton photosynthesize, producing at least half of Earth's oxygen. Zooplankton feed on them. Fish feed on zooplankton. And so the pyramid builds, but it starts with water, and with light, and with balance. Water carries carbon. The ocean is the largest carbon sink on Earth. Carbon dioxide dissolves in it, forming carbonic acid. That acid influences pH, more CO2, lower pH, more acidity, ocean acidification. Dissolves the shells of marine creatures, mollusks, sea snails, corals. It changes behavior in fish, disrupts food webs, alters the balance of ecosystems built over millions of years. Land and ocean alike breathe carbon, but the ocean holds its breath longer. Once carbon is absorbed, it takes centuries to release it. That makes it a buffer and a trap. This is not an emergency we see with sirens. It is a slow shift, a ghostly pressure, measured in millimeters, not disasters, yet it reshapes the sea and every life within it. Water influences not just biology, but physics. Its high specific heat means it stores and transports energy better than almost any other substance. This is why coastal climates are milder, why island temperatures remain stable. Land heats quickly, cools quickly. Water takes its time. The difference between a desert and a rainforest is not just heat, it's water. The heat capacity of water stabilizes ecosystems, moderates weather, drives storms. When heated, it evaporates, rises, condenses, releases energy. Hurricanes feed on this, so do monsoons, so do the smallest cloudbursts on a warm afternoon. Every raindrop began as solar energy stored in the bonds of water vapor, and when that drop falls, it returns that energy to Earth. The water cycle is not passive, it is powered. In engineering, the movement of water is work. Hydroelectric dams convert falling water into electricity. A turbine spins. A generator converts mechanical energy to electrical. Lights come on. It seems simple, but upstream, a reservoir floods land. Downstream, the natural rhythm of the river is interrupted. Fish migration changes. Sediment gets trapped. The benefits are real. So are the costs. Micro hydropower uses small channels and flows to generate power without massive dams. In coastal zones, tidal power harnesses the predictable rise and fall of ocean water. Turbines spin with the tide. Wave energy, too, is being studied. As waves bob, devices move, converting kinetic energy to electricity. Desalination is another frontier. Removing salt from seawater to produce fresh drinking water. Thermal desalination uses heat. Reverse osmosis uses pressure and membranes. Both require energy. Both produce brine, highly concentrated salt water that must be disposed of as. Demand for water rises, so will innovation. But each solution must consider more than output. It must think in cycles, because water never leaves the system. In the soil, water builds or breaks fertility. Soil moisture influences plant growth, nutrient absorption, microbial life. When water is too scarce, plants wilt, roots shrink, microbes die. When too abundant, roots rot, oxygen vanishes, erosion begins. Good soil holds water like a sponge, not too tight, not too loose. This is determined by its texture. Sand drains quickly, clay holds tightly, loam balances both. Organic matter improves water retention. Compost, humus, root systems, they hold moisture. Even during drought, tilling, however, can destroy this structure. It breaks the sponge, leads to runoff, compaction, drying. Modern regenerative agriculture seeks to preserve water within the soil. Cover crops, no-till practices. Mulching, because saving water is not just about reservoirs, it's about ground. What lies beneath our feet holds more water than most rivers combined. It's just hidden until we learn to look. In the atmosphere, water becomes visible and invisible. Invisible as vapor, visible as fog, clouds, rain. Clouds form when air cools past its dew point. Water vapor condenses around tiny particles. Dust, salt, smoke. Each droplet is microscopic, but together they shape continents. The type of cloud depends on altitude, temperature, moisture. Cumulus, puffy and bright, signal fair weather. Stratus, flat and grey, stretch like blankets across the sky. Cirrus, high and wispy, made of ice crystals. Nimbus, heavy and dark, they carry rain. Weather is water in motion. Thunderstorms form when warm, moist air rises rapidly. It cools, condenses, releases latent heat, fueling further rise. Updrafts and downdrafts cycle. Lightning charges. Rain falls. Each storm is a transfer of energy, pressure, and moisture. Even snow is sculpted vapor, frozen crystals with infinite forms. No two alike, because each forms through different paths of vapor, wind, and temperature. Even chaos follows water's rules. In fire, strangely, water participates. Steam engines powered early industry. Boiling water expanded, pushed pistons, drove locomotives. Even today, nuclear power plants use fission to heat water into steam. That steam spins turbines. The fire is not the output. The steam is. And when water extinguishes flame, it does so by removing heat and oxygen. It smothers combustion. Steam can also cause explosions, and if trapped. A pot with no release valve. A pipe with no outlet. Water under pressure becomes danger. It must move. Always, even when used to stop fire, it contains its own fire. In the East's future, water may shape boundaries, not only rivers between nations, but availability between classes. Those with money may drink. Those without may not. Privatization of water systems, bottled water industries, and extraction of groundwater for profit are increasing. In some places, water is already more expensive than fuel. Cape Town in 2018 nearly ran dry. Day zero, the projected day the taps would shut off, was narrowly avoided by emergency measures, but more cities will reach that edge, not because there's not enough water, but because it is unevenly managed. As populations grow, climates shift, and consumption increases. Access will determine futures. The next wars may not be over oil. They may be over aquifers. Yet the solution is not scarcity. It is understanding. A return to seeing water not as an entitlement, but as a shared system. One that connects homes, rivers, skies, and cells, because water it has always been enough if we listen. In human history, civilizations rose and fell beside water. The earliest urban centers were born not in isolation, but in river valleys, where silt fertilized the earth, and waters brought both life and threat. The Tigris and Euphrates cradled Mesopotamia. Here the Sumerians built canals, hand-dug furrows that tamed rivers during flood seasons. Water was channeled, stored, rationed. Cuneiform tablets recorded irrigation quotas, debts in barley, and water disputes. Further east, the Indus Valley. Civilization, in what is now Pakistan and northwest India, developed intricate water systems. Archaeologists found sewers, baths, and public wells. Cities like Mohenjo-Daro were planned with drainage grids. Water was not just utility, it was infrastructure. In Egypt, the Nile became calendar and compass. Its annual inundation dictated crop cycles. Fields were planted in its moist wake. Without the flood, famine followed. Without the river, there was no Egypt. The ancient Egyptians even personified the Nile's behavior, worshipping Hapi, the god of its floods, not with fear but with reverence. Each flood was welcomed, not resisted, and to the east the Yellow River in China, called China's Sorrow, shaped dynasties through both sustenance and destruction. Floods would periodically erase entire villages, and yet the lowest soil it left behind remained. Rich, binding the people to its cycles. Hydraulic engineering became central to the emperor's legitimacy. Controlling water was equivalent to controlling fate. In Greek thought, water was not merely matter. Thales of Miletus, considered by some the first philosopher, declared that all things originate from water. He observed its forms, solid, liquid, vapor, and inferred it must be the underlying principle of nature. Though his logic was incomplete, his intuition wasn't far off. Later thinkers, including Empedocles and Aristotle, placed water among the four elements. In these systems, water symbolized coldness, wetness, and inward motion. The humors of the body, blood, phlegm, yellow, Bile and black bile were thought to be governed by elements. Imbalances were treated with baths, herbal infusions, or changes in environment. Medicine and metaphysics mingled in the bathhouse. Rome took this idea further. Their aqueducts carried water for miles, sometimes across valleys using arched bridges, or through underground tunnels dug by hand and pick. Water entered cities via lead pipes, a marvel of engineering, and an eventual poison. Still, the baths of Caracalla and Diocletian became symbols of social health. Here people bathed not just their skin, but their minds. They read, conversed, rested. Public fountains marked wealth. Plumbing marked civilization, and behind it all there was water, flowing silently beneath marble. In medieval times, water remained central but became suspect. Rivers were no longer only sources of life, they also carried disease, filth, death. In crowded cities, waste ran into the same streams people drank from. The idea of contamination existed, but not the science behind it. People believed in miasma, the bad air, as the source of illness. So water, if still and odorless, seemed safer. Rain barrels, deep wells, cisterns, but when plague struck, water was sometimes seen as a culprit. Washing was discouraged in some regions. In others, public baths remained, but were viewed with suspicion. Islamic cities, by contrast, developed more hygienic systems, guided by religious principles of cleanliness, courtyard fountains, ritual ablutions, and strict rules about separating. Waste and drinking water helped reduce outbreaks. In some places, water meant risk. In others, it meant reverence. The disparity wasn't due to climate, but culture. In the age of exploration, water redefined distance. Ships no longer hugged coastlines. They crossed oceans. The Atlantic became a highway, and for trade, conquest, colonization. Fresh water aboard ships was stored in barrels, often fouled by algae or salt intrusion. To combat this, sailors drank diluted alcohol, grog, beer, wine, scurvy. A disease of vitamin C deficiency became common not because of food shortages, but because water and preserved foods lacked nutrients. Water dictated not only who lived or died at sea, but who discovered, conquered, and returned. On land, water determined colonial strategy. Ports were favored. Rivers were carved into canals. Swamps were drained. In places like the Netherlands, land was reclaimed from the sea, polders surrounded by dikes and kept dry by wind-powered pumps. Humanity had not yet conquered water, but it had begun reshaping it. In industrial times, water became commodity. Rivers once used for transport were harnessed for power. Water wheels spun, driving textile looms, sawmills, grain presses. Steam engines emerged, fueled by burning coal to boil water, turning pistons, powering trains. Entire cities grew along rivers, not for beauty, but for energy. But with growth came waste. Factories dumped dyes, solvents, and chemicals into the same rivers they drank from. The Thames in London became black with filth. The Cuyahoga River in Ohio famously caught fire multiple times due to pollution. Only decades later, environmental awareness brought reform. The Clean Water Act in the United States, the Water Framework Directive in Europe. Yet, even now, millions lack clean water, and billions lack basic sanitation. Technology advanced, but access remained uneven. Today, water technology spans extremes. We can drill deep aquifers. We can desalinate oceans. We can map every molecule in a drop. Smart sensors monitor water quality in real time. Agricultural drones measure soil moisture and optimize irrigation. Cities use AI to detect leaks and conserve pressure, and yet a plastic bottle of water may travel farther than the person who drinks it. A single almond requires over a gallon of water to grow. A cotton shirt. Over 2,000 virtual water, the hidden water used to produce goods, far exceeds the water we see. This disconnect is not just economic, it is psychological. We forget what water costs because we don't see where it comes from. At home, water hides in plain sight. A faucet, a kettle, a flush, yet each of these connects to reservoirs, pumps, pressure valves, treatment facilities. Municipal water systems draw from rivers, lakes, underground aquifers. Water is filtered, treated with chlorine or ozone, balanced for pH, and pushed through miles of pipe. In some cities it travels uphill, lifted by pumps that require power and redundancy. And at the end of this invisible journey, it reaches the hand, cool, clear, taken for granted. In some households, water is softened, passing through resin beads to remove calcium and magnesium. In others, it is filtered again, reverse osmosis beneath the sink, but in all places it enters the body. It cools the skin, wets the tongue, hydrates cells, carries waste, regulates temperature, and then it leaves, down the drain. To treatment. Plants or septic tanks, or into the soil, recycled, evaporated, returned. The circle is unbroken, whether seen or not. In human biology, water is not a container. It is content. The brain is 75% water, blood 83%, muscle tissue 79%, every signal. In the nervous system depends on ions moving through watery channels. Every heartbeat requires fluid balance. Every breath evaporates moisture. When dehydrated, the body becomes sluggish. Skin dries. Urine darkens. Cognition declines. Extreme dehydration leads to confusion, unconsciousness, and eventually death. But too much water can also harm, causing hyponatremia, a dangerous dilution of blood sodium. Balance is not symbolic, it is chemical. The kidneys regulate this balance. Filtering nearly 50 gallons of blood each day, they produce just 1-2 quarts of urine. This filtration is powered not by motors, but by microscopic pressure gradients. Osmosis, diffusion, membrane. Channels, it is not magic, it is engineering at the molecular level. In science, water remains mysterious. Its molecule is simple, 2 hydrogens, 1 oxygen. Yet its behavior is complex. It expands when frozen, unlike most substances, making ice float. It can dissolve more substances than any other liquid, earning the title universal solvent. It has a high surface tension, allowing insects to walk on it, and it exists naturally in all 3 states, solid, liquid, gas, within Earth's normal temperatures. No other substance behaves quite like it. Even its boiling point and freezing point defy expectations. Without hydrogen bonding, water would boil below room temperature. These bonds give water its cohesion, its shape, its life-giving power. Still, many of its properties are not fully understood. Its structure, its clustering, its response to fields. Water may be common, but it is not simple. The journey of water is never linear. It evaporates, condenses, flows. It is carried by clouds, consumed by cells, spilled on stone. It moves through time as much as space. What was once rain in the Himalayas may become sweat on a factory floor, a tear on a cheek, steam in a cup, ice on a window. It binds all living things. Not through force, but through presence. It waits and flows. In the world of plants, Water is not only sustenance, and it is structure, signaling, and survival. When a seed begins to germinate, it is not light that starts the process, it is water. Moisture seeps through the seed's outer coat. It awakens. Enzymes within. Cell walls loosen. Proteins activate. And from that silent chemical unfolding, life begins. The first shoot emerges, not toward the sun, but downward, to find more water. Roots grow not randomly, but guided by gradients of moisture and nutrients. Tiny hairs on root tips increase surface area, helping draw in water via osmosis. This process is passive, but not aimless. Water enters root cells and travels inward, from one cell to the next until it reaches the xylem, a network of vessels that functions like an elevator carrying water upward. There is no pump. Instead, transpiration pulls water skyward. As water evaporates from tiny pores, stomata, on the underside of leaves, it creates a tension, a microscopic vacuum. That pull extends all the way down to the roots. Water molecules cling to each other, so each drop that exits a leaf pulls the next one up the stem, and the next, and the next. This is the cohesion tension theory, a quiet marvel of physics and biology. A single tree may move hundreds of liters of water upward every day, not with force, but with patience. Leaves themselves are shaped by water. When hydrated, cells press outward, giving leaves their crisp structure. In drought, they wilt, not because they are damaged, but because the pressure within drops. This pressure, called turgor, helps plants stand, bend toward light, and resist wind. Lose it, and the plant droops. But water also plays a deeper role in the chemistry of photosynthesis. Inside leaf cells, water donates electrons in the light-dependent reactions. Chlorophyll absorbs sunlight. Energy splits water into hydrogen and oxygen. The oxygen escapes into the air, the very air animals breathe. The hydrogen continues through the cycle, helping form sugars. So every starch, every fruit, every grain began with a broken water molecule and a moment of light. In drought, plants adapt. Some close their stomata during the day to conserve moisture, opening only at night, like cacti. Others develop deep taproots that reach down meters into dry soil. Some grow small, waxy leaves that lose less moisture. Still others store water inside, thick succulents, swollen trunks. These adaptations are not recent. They are millions of years in the making. Water scarcity shaped the flora of entire regions. Savannas, steppes, deserts, all bear witness to survival through scarcity. But when water returns, in rain, dew, mist, the revival is rapid. Deserts bloom, seeds awaken, barren land turns green in hours. This resilience is coded into water. In animals, water is motion. Blood flows because of water. Nutrients dissolve because of water. Hormones travel because of water. But animals also use water behaviorally. Elephants dig wells in dry riverbeds, using memory and scent to find hidden underground water. They drink, then let others, antelope, birds, warthogs, share the pool. Camels don't store water in their humps. They store fat, but their bodies can lose up to 25% of their water and still function. Their blood cells are oval, not round, which helps them flow even when dehydrated. The kangaroo rat may live its entire life without drinking. It survives on metabolic water, the small amount produced when its body breaks down seeds. Some frogs survive dry seasons by burrowing underground and forming a cocoon from their own skin, retaining internal moisture for months. Water determines movement, migration, mating, even memory. In dry seasons, herds move not toward grass, but toward water. Predators wait there. So do risks. But the body obeys thirst. It must. In culture, water is more than need. It is symbol, story, and spirit. Almost every religion references water as cleansing. In Christianity, baptism symbolizes purification, water poured or immersed to wash away sin. In Islam, ablution before prayer, wudu, involves washing the face, hands, feet. In Hinduism, rivers like the Ganges are sacred, believed to wash away karma. In Judaism, mikveh baths are used for ritual purity. Even outside religion, water remains ceremonial. Tea rituals in Japan involve precise pouring. Rain dances in Native American tribes call for clouds. Fountains in public squares mark not only beauty, but shared wealth. In language, water is metaphor, calm as still water, drowning in work, a wave of emotion, a stream of thought. Tears flow, words trickle. These are not coincidences. They are echoes, because water is not only substance, it is experience. In music, water shapes sound. Instruments mimic its rhythms. Gurgling flutes drumming rain sticks, cymbals crashing like waves. Musicians record oceans to add depth. Composers from Debussy to Smetana wrote pieces inspired by rivers, the babble of a brook, the stillness of a pond. These carry moods, and in film, water builds atmosphere. A dripping tap in a thriller, a rushing river in a chase, a quiet storm outside a window. In sleep apps, water dominates soundscapes, rain, waves, trickling fountains, because its rhythms align with our breath. A slow drip mirrors a resting heartbeat. A crashing wave times with our inhalation. A still lake quiets the mind. In memory, water is emotion. We remember swims from childhood, the first rain of spring, a cold drink after heat. These are not just tactile, they are neurological. The hippocampus, the brain's memory center, lights up when we feel immersion. Smells of rain trigger ancient memories. Sounds of water reactivate calm states. This is why bathing soothes, why waterfalls draw us in, why even imagining water reduces stress. In one study, hospital patients with a window view of a fountain healed faster. In another, walking near water reduced cortisol levels significantly more than walking in urban spaces. Water doesn't just heal the body, it lowers the mind's noise. In the home, water rituals define routine, morning showers, tea before bed, soaking dishes, washing hands. These are not merely practical, they mark transitions from sleep to wake, from work to rest, from outside to inside. Warm water signals safety, cold water signals alertness. Even the sound of a shower, white noise, masks interruptions, helping us think. At night, a glass of water on the bedside table becomes a symbol of preparation. Not thirst, but care. It says, "If you need me, I am here." In infrastructure, water connects. A city's plumbing is a circulatory system, hidden, vast, complex. There are supply lines and return lines, storm drains and sewer mains, pumps, pressure. Regulators, filtration plants. A single leak can cause a block to lose water. A clogged pipe can flood a basement. A contaminated well can sicken thousands. Engineers plan for redundancy. Hospitals have backup tanks. Fire hydrants are tested monthly. Meters monitor flow, and beneath it all are people whose job it is to keep the water moving. Meter readers, pipe fitters, water quality technicians. Their work is quiet, but essential. They ensure that when you turn the tap, something flows, and when you flush, it goes away. In the cosmos, water remains a question. We found frozen water on the Moon, vapor plumes on Europa, a moon of Jupiter, ice caps on Mars, possibly water clouds around distant exoplanets. Every time we find water, we ask, could there be life? Because we don't know any life that exists without water. It is not only essential, it is the signpost we follow in the search for others. Rovers on Mars have drilled for it. Telescopes have scanned infrared spectra for its signature. Future missions aim to land where water might lie beneath ice. If we find it, we may find company. And, if not, we still find awe, because even if no one else drinks, breathes, or dreams, the water remains, ancient, unmoved, waiting. So water begins nowhere and ends nowhere. It just continues, as mist, as flood, as tear, as cup. It loops not in circles, but in layers. Every drop has touched mountain and mouth, cloud and stone, child and ancestor. It has boiled in volcanoes, frozen in comets, fallen in love stories, shed in grief, and still it returns. In the world of technology, water is paradox. It is both the enemy of machines and their most essential component. Electronics fail when exposed to moisture, corroding, short-circuiting, degrading. Yet the production of electronics demands enormous amounts of water. To make a single microchip, the small silicon wafer inside computers and phones, manufacturers require ultra-pure water, not just clean, but pure to the level of 1 contaminant molecule per billion. This water rinses, etches, and cools during fabrication. It's produced in high-tech water plants using filtration, ion exchange, reverse osmosis, and UV sterilization. Factories in places like Taiwan, South Korea, and the United States use millions of gallons per day. This creates a strange dependence, cutting-edge digital futures, riding atop ancient molecules. Even in cloud computing, the term feels weightless. The physical reality is grounded in water. Data centers that house servers for the internet generate enormous heat. To prevent overheating, they rely on water cooling. Pipes loop water through racks of processors. Towers vent warm water into the air. Massive facilities may consume as much water as a small town. The digital world flows because water flows. Silently behind it, in industry, water is input, output, and cost. It dissolves chemicals, cools steel, washes food, carries waste, separates oil from sediment, but few see these flows. A cotton t-shirt, simple and soft, may take 2,700 liters of water to produce. A hamburger, from growing the grain to raising the cow, requires over 2,000 liters. These are invisible waters, virtual waters. And when industries relocate, it is not only for wages or laws, it is often for water. Bottling plants appear near, freshwater springs, paper mills near rivers, chemical refineries beside lakes. The price is not only paid in labor, it is paid in watershed. Pollution from industrial runoff, lead, mercury, nitrates, can linger for decades in aquifers. Some toxins bind to sediments, re-released during floods. Others bioaccumulate, entering fish, then birds, then humans, and yet regulation remains slow. Invisible water escapes notice. In cities, water divides. In wealthier neighborhoods, pipes are newer. Water is pressurized, filtered, constant. Homes have multiple bathrooms, dishwashers, decorative fountains. In poorer areas, water may be rationed. Infrastructure may be outdated. Pipes may leak or rust. Contamination may go undetected. In some regions, people walk miles to fetch water from shared wells. In others, they receive bills for bottled water deliveries, priced higher than fuel. Some drink tap water without fear. Others boil every drop. Access is not equal, it never has been. Globally, over 2 billion people lack safe drinking water at home. Over 3 billion lack basic hand-washing facilities. The burden falls disproportionately on women and children, who often collect water daily, walking hours, carrying weight, missing school. Their backs carry what pipes do not. In law, water raises questions. Who owns it? A river that flows through 5 countries, a spring that begins on private land, rain that falls freely but is captured in barrels. In some regions, water rights are tied to land ownership, in others, to usage. Some countries treat water as a public trust, others as a commodity. Conflicts arise. Farmers compete with cities, factories with fisheries, upstream with downstream. Lakes shrink, glaciers retreat, desalination plants expand. Pipelines are debated, and as climate changes, and with more droughts, longer dry seasons and fiercer storms, water politics intensify. In the 21st century, wars may no longer be for oil, but for water. Already, in places like the Middle East, Central Asia, and Sub-Saharan Africa, water tensions simmer beneath headlines. Sometimes not as war, but as migration. When the well runs dry, the village moves. In art, water is never literal. It is mirror, mood, and movement. Painters depict it in shimmering brush strokes. Monet's lilies, Turner's storms, Hokusai's waves. Sculptors freeze. Its motion in marble. Photographers wait hours to capture its stillness. Writers use water as metaphor for love, memory, grief, hope, a river that forgets nothing. A drop that starts an ocean, a sea that cannot be crossed. In film, water reflects character. Still pools for contemplation, rain for transformation, floods for chaos. Even in video games and virtual worlds, water simulation is a technical milestone. Physics, refraction, ripple. Why? Because water is what we look for when we want something to feel alive. In the body, water is not background, it is rhythm. Each cell maintains its own water content. Too much or too little disrupts balance, function, survival. Water moves across membranes by osmosis, a passive flow yet precise. Sodium, potassium, calcium all depend on water's pathways to trigger nerves, muscles, hormones. The hypothalamus monitors hydration. If levels drop, it signals thirst. The brain urges drinking, not casually, but biologically. Even mild dehydration, 1 to 2% of body weight, impairs attention and memory. In athletes, it slows reaction. In children, it reduces learning. In the elderly, it increases confusion. Hydration is not preference, it is precision. Water helps regulate temperature through sweat, blood flow, breath. It cushions joints, lubricates eyes, moistens lungs, cleanses kidneys, transports hormones, protects the brain inside the skull. It is not only in the body, it is the body. In time, water is patient. Rivers carve canyons, glaciers grind mountains. Rain wears stone, floods rearrange valleys. Over millennia, oceans rise and fall, shorelines shift. Lakes appear, then dry. Ancient water still exists, in underground aquifers sealed for thousands of years. Some of it predates agriculture, some even older. Ice cores drilled from Antarctica contain bubbles of ancient air, tiny snapshots of climate history. In these frozen cylinders, water records time. Through layers of snowfall now compacted into ice, Scientists measure temperature, volcanic ash, atmospheric gases. It is a library. Written in crystal. Read in silence, and water does not hurry. It evaporates when heated. It condenses when cooled. It moves with gravity. It waits in clouds. It falls, seeps, runs. But it never forgets. In death, water remains. A body returns to earth. Moisture leaves. Skin. Organs dehydrate. But water returns to soil, to air, to roots. It becomes part of the cycle. Not metaphorically, chemically. The water that once carried thought might later carry root. And in this quiet science, nothing is lost, only changed. In sleep, water persists. The body cools slightly. Breathing slows. Cells repair. Brain waves shift. Yet water continues its work. Lymphatic flow increases, clearing waste from the brain. Hormones regulating hydration adjust for overnight balance. Saliva production reduces. Tears recede. But water remains. In dreams, oceans appear, storms, rain, tides. The mind remembers water, even when eyes are closed, because the brain itself floats in water. Cerebrospinal fluid cushions it, bathes it, carries nutrients, removes waste. It is not surrounded by blood, but by clear liquid. Even thought rests in water. In the end, the story of water is not a story. It has no beginning, no climax, no moral. It is not a character, it is the setting. Every breath contains water vapor. Every touch leaves moisture. Every sentence spoken exhales tiny drops. We are not near water. We are in it, we are made of it, we return to it, and it carries on. Good night.